Miguel says, Mono is a trick to get Microsoft to pay for the marketing of C#. So we get the benefits of having a larger amount of developers, but write applications for Linux. Well, one example is the Java IKVM library, which is a Java virtual machine which runs on the CLR and Mono. And Iron Python itself. It was surprising that a couple of hours after it was released, people were running Mono test. So we wanted that. And yes, we also wanted to reuse third-party compilers for AFL, ADA, Fortran, or whatever that compiles to the CLR. Mono has the basic virtual machine and runtime, which are close to the ECMA spec, and then we have two stacks: the Microsoft compatibility libraries, which deal with mostly with the portability of code from Windows to Linux. So we provide ASP.NET support. We provide database access support. We are writing an implementation on Windows Forms, and so on. And then we have the free software stack, which provides access to the Unix graphical libraries, to LDAP, and whatever. For example, if someone is writing a binding to be able to use Mono inside Mozilla. Mono started 3 years ago. We were initially 4 and then 5 people at Ximian, and a year ago, Novell acquired Ximian. Since then, a few other people joined the team, and we have a large community of contributors, 200 or 300 developers contributed fixes and features. And we also get help from companies that use Mono commercially, Mainsoft, SourceVR, a couple of embedded system vendors. And we also try to reuse existing free software. So we took the Bohem garbage collector. We looked at the ARP virtual machine. We are using IBM ICU Unicode library, and so on. The virtual machine executes. There are two execution engines. An interpreter which is used just to help bootstrapping and debug new ports to new architectures, and an asset code generator, which can be used both as a just-in-time compiler and as an ahead-of-time compiler. So we can generate the code from a library, save it to disk, and the next time the runtime startups will use the code from the on-disk copy. This is helpful to reduce startup time. And we haven't developed this part fully in the sense that we are not sharing code pages, because one of the reasons to generate code and save it to disk is also to share the code between different processes. And we aren't using this feature fully because when we generate shared code, the code is not as fast as generating the code just in time, because we need additional references to access data. So this is still a disabled feature because it's not fast enough, or at least not as fast as we'd like. The mini just-in-time compiler uses two intermediate representations. The first is a tree-based representation that is created directly from the IL code. Most of the optimizations happen on trees. And then we have a bottom-up rewrite system to turn into a list of quadruples, which are instructions which are close to a machine, to a single machine structure, but not really the same. Mostly they map pretty well on RISC machines, but they are very close to single instructions in the CPU. We have a few optimizations. The simple ones, or well, the optimizations which require little time are enabled by default, and we have a switch which can be used on the command line to enable the more expensive optimizations. And we plan to do online profiling to do reconciliation of methods in the future. One of the objectives of Mono is also to be able to use the Mono virtual machine inside other applications. We don't want people to throw away their code they're writing in C#. We want people to be able to reuse their code and start using Mono and new languages at their own pace. So they can start supporting Mono to write plugins, for example. An application, an Office application who wants to have a scripting can just embed Mono, and all the languages that map to the CLR can be used to script the applications. Instead, at this time, an application would need to link against libperl, against the Python library, Ruby, and so on. The other reason for embedding Mono is to be able to compile methods on the fly. For example, think of an image manipulation program which has a filter, and the user selects some constants. The JIT will be able to optimize the code and get the filter to execute faster. So we plan to export also an interface that can be used from C programs to directly generate JIT code. What are we doing next is to improve stability, speed, to support the applications that Novell is developing, both on the server side and on the desktop side. And we wanted to continue to support integration with Java using IKVM and the other runtimes. We already support Iron Python, but we also wanted to support the development of Tcol, Perl, and whatever runtimes that people may want to need. We don't have a good story on debugging. Currently, you can use GDB to debug the virtual machine, and you'll have to be able to read the machine code for the JIT code. We have a debugger in the works, but it's not ready at all. Okay, Mono 1.2 should be released at the end of the year or early next year. It will have a few improvements. The initial implementation of Windows Forms, a Visual Basic compiler, Visual Basic .NET compiler, the C# compiler, we'll have the feature of C# 2.0, such as generics, iterators, and so on. And the JIT has already been ported to Spark 64, AMD 64, and S390. We also have improved the speed in most